This is a portable handheld computer released in 2025, but it feels much more like a retro 8-bit computer, even if it is a lot more capable than those. It's made with the intention to be programmed, hacked and expanded by the user, just like the 8-bit computers of the past, and it also plays games. This is PicoCalc by Clockwork. The flexibility of what this thing can do actually makes it a bit confusing to get started with PicoCalc. So in this video I will show you a bunch of things that I've found to do with it. But first, let's take a look at the hardware of this device. When you receive your PicoCalc, you actually have to assemble it yourself. But don't worry, it's quite easy and just part of the fun. The manual is easy to follow and there are only a few components that need to be assembled. You start by putting the small speakers into the front part of the case. These connect later by little spring connectors that push onto the main board. Then you place the screen onto the front case and next the keyboard keys. Then you get the main board and you have to remove these little plastic tabs on the header connector to be able to insert the Raspberry Pi Pico, which is included in the package. This is the brains of this device. It comes with a non-Wi-Fi Pico 1 board, but it supports the Wi-Fi versions of both Pico 1 and also Pico 2, which has twice the amount of RAM and flash space, as well as a faster CPU. Then you place the main board on the front part of the case and thread the screen ribbon cable through, and push it into the connector and click the lock into place. Remember to insert the included SD card. Surprisingly, it's a full-size one and not a micro SD. Then the back part of the case can be screwed into place, holding everything together. Finally, you need to place the protective tempered glass cover in front of the screen. And you're done. PicoCalc doesn't come with batteries, so you'll have to supply your own. It takes regular 18650 LiPo cells. Just make sure to orient them correctly when inserting them to match the polarity. You can charge the batteries by plugging in a charger into the USB-C connector on top. Behind it is a micro USB connector, which is used for flashing software. Next to this you find a headphone jack and on the other side the on-off button that you need to hold down to turn it on. On the right side you can access the SD card and on the left you find some GPIO connections. You can apply this label sticker which is found in the manual, and next to those is a volume knob. You can flash various kinds of firmware onto the Raspberry Pi Pico inside this device. It even comes with a Nintendo emulator that I will show you later. But first, let's take a look at the pre-flashed firmware, which makes it feel a lot like a retro 8-bit computer. I had a Commodore 64 as a kid. On top of the pile of comic books next to my bed was the programming manual that I read through every night, and I was amazed by it. Back then, every computer was sold with the intention of the user to learn programming and how the computer worked. When you turned on the computer, it instantly booted into a programming prompt, and this simple programming language immediately available to the user was called BASIC. It allowed you to very easily create if-then-else statements, loops, manipulate variables, and create graphics and sound. PicoCalc comes pre-flashed with an open source operating system with a built-in basic interpreter for Raspberry Pi Pico devices, known as PicoMite, which is itself a port of MMBasic. Just like different 8-bit computers back in the day, this specific version of BASIC has its own quirks and commands that you will have to learn to take full advantage of its capabilities. And not every BASIC script you find will necessarily immediately work. You can download the PicoMite manual from the PicoCalc GitHub repository, and reading through it gives me that exact same nostalgic feeling I had as a kid reading through the Commodore BASIC programming manual. To open the built-in editor, type Edit, or use F4 as a shortcut. Here we can type in a simple script. Labels are defined by putting a colon at the end, and we can use the goto command to go to that point in the script. To save and exit the editor, press the F1 button. You can now type Run to execute or press the F2 button as a shortcut. To stop a running program, hold Shift and press Escape. You can type Memory to see how much free memory you have. Whatever program is currently in memory stays there even if you turn the device off and on. You can type New to erase whatever is currently in memory. Just by using a few simple commands, I've made this simple higher or lower game, where you have to guess which random number it has chosen, and it will give you hints along the way. The SD card comes with a few different basic programs that you can load and run. To access files, simply type Files. This will by default list drive A, which is the internal flash memory. To switch to the SD card, simply type B:, and then Files again. To load a file, type Load and then the file name in quotation marks. I will load this Lorenzo animation that comes on the SD card and then press F2 to run it. You can always open the editor to see the source code of the loaded application to try and understand how it works. You can also load other files than applications. Load Image will let you open image files. The screen has a resolution of 320 by 320, so your images will have to be this size or smaller. And Play Wave will let you play back wave audio files. I've made this little script that loads my logo, outputs a message, and plays back a sound file from the SD card. It's actually possible to have this load automatically on startup instead of the default greeting. We can do this by saving the script in one of the 3 internal flash slots by typing flash save 1 and then typing option auto run 1. And now it runs automatically on every startup.
Greetings, Professor Vulcan.
By default, the text on the screen is green on a black background, but you can also customize this by using the color command and defining foreground and background colors separated by a comma. Colors in PicoMite are defined through a 24-bit color number, which can be generated by the RGB function, either by using one of the default color names or by entering red, green and blue numbers from 0 to 255. By using this command, you can easily create your own startup script that configures the colors to be whatever you prefer, but obviously I like green. You can also use the command font and a number to change between 8 different built-in fonts, or you can download custom fonts or even define your own. Another useful command is CLS, which clears the screen, and this can also be suffixed by a color to make the screen background this color. You can also use F5 as a shortcut to clear the screen. By using the random function, RND, I've made this script that flashes the background in random colors, or this other script that creates random size, color and position circles. This user on GitHub has made a small collection of basic applications that are converted to work on PicoCalc that I will link below, which includes various games like the 1970 version of Oregon Trail, a Zork-like adventure game, and a better higher-lower game than the one I managed to make. On the left side of the PicoCalc you will find some GPIO pins, and these are addressable in PicoMite as well. I've connected an LED to pin GP28 and ground, and made this little script that makes it blink. It's also possible to communicate with various modules and sensors, much like the GPIO pins on a Flipper Zero. Oh, and by the way, you can turn on the keyboard backlight by holding Alt and pressing the spacebar. You can adjust screen brightness by holding Alt and pressing these 2 bracket buttons, and you can check the current battery level by holding Alt and pressing B. The power LED will blink 1, 2 or 3 times depending on the battery left. And if the power LED starts flashing continuously, it means the battery level is very low. PicoMite wasn't made for PicoCalc. It's a pre-existing open source project that can be used with Raspberry Pi Pico in various configurations. So not everything in the manual is relevant to your PicoCalc. But PicoCalc really makes it easy to use PicoMite, and I will highly recommend that you read through the manual to understand the various capabilities and handy shortcuts. As of the making of this video, PicoCalc is still a very new device, and I'm very much looking forward to all the cool software and games people will make using PicoMite, because it's much more capable than these simple examples. But PicoMite is just one of several available firmware files. Let's next take a look at the NES Emulator. On the SD card that is supplied with your PicoCalc is a folder named Firmware. Copy this folder to your computer. Put the SD card back into your PicoCalc and make sure that it's turned off. On the back of your PicoCalc you can see the Raspberry Pi Pico through the vent holes, and you can just about use something thin to poke the boot button on the Pico board. Hold down this button while plugging in a micro USB cable from your computer into the board. It'll now appear as a drive on your computer, and you can stop holding the button down. Drag and drop the PicoCalc NES UF2 file from the firmware folder onto this drive. This file will now automatically be flashed onto your Pico, and once it's done it will eject the drive and you can unplug the cable and turn on your PicoCalc. You will now be presented with a list of .NES files that are found on the SD card. It comes with a chess game, but you can also put your legally acquired ROM files onto the SD card. Use the arrow buttons to select a game. The square bracket buttons work as B and A, and the minus and equal buttons work as select and start. To get out of a game and go back to the game selector screen, hold down the select and start buttons. Unfortunately, far from every game works in this emulator. Some don't load at all, and some display distorted graphics, but some also plays just fine.
Another interesting included firmware to load is uLisp, which is an interpreter of the programming language Lisp, which can be used to render some interesting graphics on your PicoCalc.
uLisp loads into a prompt much like PicoMite does. But to be able to load pre-made Lisp files from the SD card, you first need to meticulously type in this short loading program, being careful to type everything just right. You only need to do it once though. Just make sure to type save image at the end, and then you can load the loading program from the flash memory again by typing load image after booting up uLisp. You can now load .lisp files from the SD card by typing load filename lisp. Usually they will have some custom function call that you need to execute to make it do something. Once you get it working, it can create some beautiful mathematical patterns. I will link to these code examples in the description below.
Another interesting included firmware on the SD card is Fuzix, which is an entire little Unix operating system.
This operating system has been developed to be used with retro microprocessors like the Z80, but is now also ported to run on the Pico. Since we have no real-time clock, we have to input the current date and time on boot up. The default user is root with no password. You have a few different typical Unix commands and applications available by default. In the USR Games folder you can find a text adventure game and the ever-inspiring Cowsay application. Oh, and right as I'm making this video, someone has actually forked Fuzix for PicoCalc and has started adding new features and support for Pico 2. Things are moving fast.
PicoCalc comes with all these different firmware files and also this MP3 player. But let's take a look at a much more modern programming solution, which it's also possible to load, but isn't included in the SD card. And that's Micropython.
The default Pico 1 board the PicoCalc comes with doesn't have Wi-Fi, but I want to do something with Wi-Fi with this Micropython setup, so I'm swapping out the board for a Pico 2W instead. Make sure to order one with pre-soldered header pins. Remove the batteries before swapping it out. Actually, I wish there was a little door in the back of the case, so that I could switch out boards without having to disassemble it every time. Then I could keep a few different boards with me, flashed with various firmwares. They are quite cheap after all. The 3D files for the case are actually available on the Clockwork website, so someone could design a 3D printable alternative. Go to the PicoCalc Micropython driver GitHub and click download zip. Hold down the boot button on the Pico board and connect the micro USB cable to your computer. Drag and drop the UF2 file suitable for the Pico board in your PicoCalc. Be aware that any firmware file you flash has to be compiled for the specific Pico board you're using. If you turn on your PicoCalc now, nothing will display on the screen. You first need to load some Python files onto the internal flash drive inside the Pico board. You cannot use the SD card at this point. To do this, download and open the application named Thonny. Turn off your PicoCalc. Connect the micro USB cable to your computer. Turn on your PicoCalc. In the bottom right of the Thonny application, you can now select your PicoCalc to connect to it. In the menu, click View and Enable Files. On the left you can see your local files up top, and below it are files on your Raspberry Pi Pico board internal flash storage. Locate the Micropython PicoCalc folder you downloaded earlier and click the file named main.py and select Upload to root. Do the same for FB Console and PicoCalc. You can now unplug your PicoCalc and turn it off and on, and you should see the Micropython prompt on the screen and be able to type in code and commands. There's a huge online library of Micropython projects available that you can load onto your PicoCalc. Files that you have placed onto the internal flash memory can be loaded by typing import filename, and any functions defined in them will be available from this prompt. You can also have files be loaded automatically by putting the import filename command into your main.py file, which is loaded on boot. This is also how the PicoCalc display and keyboard drivers are loaded. you can edit the files on your Pico directly from the Thonny application. I really wanted to have a ChatGPT client on this device. And what better way is there than to simply ask ChatGPT to write a Micropython client? So I did, and it works great. The script connects to my Wi-Fi and defines a function that can be called to ask ChatGPT anything. A good example of how PicoCalc is also capable of interacting with networking and managing data in a much more effective and flexible way than the simpler PicoMite MMBasic environment. And I'm sure someone else will figure out a way to interact with the SD card.
We are still in the very early days of PicoCalc software, and it has a far greater potential than these simple implementations I've shown in this video. There are lots of projects for Raspberry Pi Pico devices that could potentially be made to work on PicoCalc in the future.
PicoCalc clearly gets its design inspiration and name from graphing calculators, which also have a history of bored students poking around and making them do things they weren't supposed to do. Even though PicoCalc is not a graphing calculator, you can definitely make it do calculator things with the right programming inside. But if what you need is a calculator, just get a calculator instead. The company behind PicoCalc, known as Clockwork, also makes another handheld computer named uConsole, which I've also made a video about. uConsole runs off a full-blown Raspberry Pi compute module, which is much more like a normal modern computer running a regular Linux operating system and regular applications, networking, and USB devices. uConsole is definitely more capable than PicoCalc, but uConsole is also much slower to boot up, and it's more cumbersome to use modern graphical applications on the small screen.
PicoCalc is also a lot cheaper, and unlike the uConsole, which took me 9 months to receive, PicoCalc arrived in less than a month after I ordered it.
Besides scratching my retro computing itch real good, PicoCalc also has a huge potential for custom software and hardware hacks. As I've shown in another video, the video game module for Flipper Zero also runs off the same RP2040 microcontroller, and we're beginning to see Pico projects being ported to the video game module. The keyboard on PicoCalc is very nice and clicky to type on, even though it occasionally fails to register a key or registers as a double press. But I think this might have to do with the keyboard debounce firmware that hopefully can be fine-tuned in the future like it was with the uConsole. Most of the time it works just fine though. I really like the IPS screen, which is not only very clear to read, but the square format is much appreciated for typing out text and displaying retro graphics. And it's nice to see that they didn't just go with an annoying, easy to get widescreen instead. One really annoying thing about the PicoMite software specifically though is that you cannot write lines in the editor that are longer than the width of the display. You can work around this with some creative use of variables, but hopefully this is changed in the future. The PicoCalc case is plastic, but I think it feels pretty good. It makes it feel a bit like an old Game Boy. It's a really nice size to hold in your hands, and I feel like I have to be less careful when putting it down compared to the much heavier metal case of the uConsole, which might scratch your table. I've designed this 3D printable stand for PicoCalc, and there's a link in the description. I can't tell you how much use you can expect to get out of a single charge of the batteries, because even though I've been playing around with it a lot, so far I haven't managed to run down the batteries yet. I can see lots of potential for various interesting apps for PicoCalc. I know I would like a nice BBS client. PicoCalc could also be used to control the same types of modules that are available for Flipper Zero, like infrared sub-GHz and ESP32, just with a much bigger screen and a physical keyboard. It could be used as a keyboard and screen for Mestastic devices. You could probably fit one inside the case. And also more games could definitely be ported to PicoCalc. Red Alert is already capable of running on a Pico for instance, and so is Doom. Another interesting option is to simply not use a Raspberry Pi Pico in your PicoCalc at all. There is a pin-compatible board called Lockfox Lyra available, which has a much more powerful ARM processor, and there is already work being done to make this work in a PicoCalc, along with a Linux environment, bringing it much more into the category of something like the Raspberry Pi Zero-based handheld computer called BP, which I've also made a video about. Quite a few games and software is already ported to work on the Lockfox Lyra board, as well as some hardware hacks.
I really like handheld computers, and this is an awesome one. It's a relatively cheap, great platform for doing all sorts of programming and hardware modifications. And its limitations just bring out that creative mindset that was required back when all computers were even simpler than this one. I hope I've given you a small insight into what the clockwork PicoCalc is all about.